Hi everyone, in this series I will start a new set of videos about IoT and software development in Python. My name is Dimitri and I work as embedded software developer. So what is IoT? IoT stands for Internet of Things, and in this sets of video I will show how to connect different equipment, sensors, Bluetooth, ESP32. It is always fun to work with real things, not only with poor cloud. So let's get started. So we're going to work with IoT, and naturally we need some hardware for that. The first part is a Raspberry Pi. It's a Linux-based computer that doesn't have moving parts. It works from USB. It has plenty of GPIO ports and it good fits for our needs. Then we will need some LEDs and resistors. Keep in mind that LEDs has a polarity, so anode should be connected to the plus and cathode should be connected to the minus. And we also need some wires. I think they're officially called DuPont wires. You can easily find them on Amazon. They can be male and female, so we can easily plug all things together. As I mentioned, no soldering will be required, so we will need only a breadboard to connect all pieces together. So we connect wires, LEDs and resistors. The connection diagram is shown on the screen. It's pretty easy. We have a ground pin and we have 3 pins that we will use as an outputs. This is our final design. Here we have a ground line, we have 3 GPIO pins, they are connected to LEDs and each LED has a current limiting resistors. So let's start testing. First let's start with the environment. As we can see, I am using Visual Studio Code as my editor, but I am edit the code on the desktop and it will be executed on the Raspberry Pi, so I need to copy the files. And here we have 2 options. I'm using skp command to copy the file, so I can run this command manually. The second option is to use the script to automate this process. The skp command is available for Linux and macOS, and there is also a Windows version called WinSKP. And when the file is copied, it can be used on the Raspberry Pi. There is an important note: we need to enable SSH on the Raspberry Pi, otherwise we will not be able to connect. And when the file is copied, we can actually run it. Okay, now we're ready to start actual coding. First I need to import Python GPIO library that I will use to control the pins. Here I'm also importing the time library that I will use for the delay. As a next step I specify the pin numbers. As we can see, this is a convenient Python feature. I can set 3 variables in one line because we have 3 LEDs. On the Raspberry Pi, pins can be configured as an input or as an output. Logical 1 on the Raspberry Pi is the voltage about 3.3 volts, and the logical 0 as an output is a voltage about 0 volts. And I set the default state to false, so the output will be 0. Okay, as a simple approach, let's see how it works in practice. As a first example, I can just change the pin states from 0 to 1 and back in a loop. As we can see, the code is simple. I set all pins to true, then there is a delay, and then I set all pins to false, and then we can run the code. And we can see it is blinking. And now let's do something more fun. I will show how to encode a sequence. I will delete these. First is a sequence I want to execute. Here is another convenient Python feature. I can use 3 values in one loop, so I immediately have access to first, second and third LED. And now we can run this code. As we can see, it works well. As a bonus, let's test another fun approach. Let's say I want to connect a powerful LED strip. As a first naive approach, let's connect it directly, and of course, as we can see, it doesn't work. The reason is that the Raspberry Pi cannot produce enough current for these LEDs. What is the solution? We need to use a special driver that will act as a switch and will allow us to handle much more current. The connection is actually simple. You can see a diagram on the screen. As we can see, I have a 12 volts power supply that is used for the LED strip. The Raspberry Pi output is connected to the input of the driver, and it actually works as a switch, so it can handle this current. And we can see the result, the LEDs are blinking. Okay, now everything works as expected, and I will answer the last question, how to run the app automatically during the boot. Let's say we created a nice app, but obviously we don't want to run it manually. Well, there are two options for that. The first one is to use rclocal, but for some weird reason in the latest Raspbian it is removed from the system. So instead of rclocal, I will show a professional way to run the app is to create a system service. For this we need a special service file that you can see on the screen. The main part of the file is the command that actually runs our app. And there are several commands that we can execute. We can enable the service, we can disable the service, start it and stop it. So technically it's a pretty convenient way. Now as example I enable the service and now I can start it and our LED will blink. And when a service is started and enabled, we can reboot the Raspberry Pi and it will run automatically what we expected. Let's see how it works. The Raspberry Pi boot takes about 20 seconds, so we can see that the LEDs are off, and then after a small delay the app starts, so our system service is running. That's it for this video. If you enjoyed it, please press like and subscribe. In the description you will find a link to the Patreon page where you can find the source code, and this support helps me to buy different sensors and equipment that you saw in the video. I have more ideas, and in the next video I will explain how to use Raspberry Pi inputs. Then we can use different sensors, and if you have any ideas of what do you want to know, feel free to write in the comments and I maybe create a special video for that. See you next time.